Okay, section 7.3, page 730 is all about circles. Okay, now we've done some of this already. Okay, we're only going to scratch the surface of circles. Okay, really stuff we've kind of done already. Circle looks something like that, right? I've got a center point, and the distance from the center point to the edge of that circle has a name. We call that the radius. Okay, we'll represent that by letter R. The distance all the way across the circle has a name, which we call the diameter, which we'll use letter D for diameter. Okay. The distance around that circle. Okay, we use the word perimeter in all cases of polygons, but when it comes to a circle, we have a different name. But it really is just the perimeter around, but it's called the circumference. Okay, letter C. And then if I wanted to figure out how much surface does that circle cover, that's good old area, just like we had area for other objects, okay, other shapes. So really that's all we're going to do. We skipped the first section of chapter 17 talking about lines and angles, and there's lots of angles to be talked about with a circle. You know, you go around the circle, all the way around would be what's called 360 degrees. There's another unit of measure for angles called radians. All the way around a circle would be what's called 2 pi radians. Unfortunately, we're not going to cover any of that in this class, or maybe I should say fortunately. Okay, we're just going to cover the basics of circumference and area in our course here. Okay, so let's talk about 2 little formulas. This is something I would expect you to know from memory. Circumference C is equal to this Greek letter pi, which we've seen before. It's an irrational number. There's a button on our calculator that has it. It's approximately 3.14. Okay, squiggly equal sign means approximately. Okay, it's really a number that goes forever. Okay, but that's a constant as far as we're concerned. Pi times diameter gets me the circumference. Okay, now the diameter is twice as long as the radius. So another way to say the same thing would be 2 times pi times radius. Okay, that's the same thing as pi times diameter. 2 times pi times radius. Okay, area of a circle is pi times radius squared. Okay. If we wanted to think in terms of diameter for some reason with the area, we can do it also. That one's a little less obvious to see, but it's pi divided by 4 times d squared. Okay, so these are interchangeable. Okay, these are interchangeable. One involves the radius and one involves the diameter. Radius is just half of the diameter. Okay, that's all. Okay, so we're going to use these formulas now to do some calculating of areas and circumferences. That's really all we're going to do in this section. So if we look at example 1, find the circumference to the nearest tenth of a meter. So we're going to round of a circle that has a diameter 1.3 meters. Okay, find the circumference. Okay, well, circumference equals pi times diameter. I'll leave it as pi. We'll use our pi button on our calculator. I've got a couple different calculators going at my desk here, so I'll just grab the closest one. Might not match yours exactly, but that's okay. We need to find our pi button. Now mine's right there, so pi times 1.3 equals, oh come on, 13 pi. That's not what I wanted. Boy, that's what happens when I grab an unfamiliar calculator. Let me grab a different one. Watch, I'll get screwed again here. Pi. Now I gotta find pi on this one with the clock ticking. Sometimes you gotta hit like a shift button. Okay, oh boy, it's gonna give me the same stupid thing, I bet. Equals, no, okay. Pi times 1.3 equals 4. 0.08407. I could have done it on that other calculator, by the way. There's a way to make it give you a number and not the pi character. I just didn't want to sit here on camera and try to figure it out. Okay, so I've got a bunch of decimal places there. What's my unit going to be? Well, circumference. I just have one unit of length involved, so it's just going to be meter. Okay, 4.08407 meters, but we were given some instruction here, I believe, right? Round to the nearest tenth of a meter. So I'm rounding to right there. And rounding to right there is going to give me 4.1 meters. Okay? There we go. Easy peasy. What's example 2 have to say for itself? Find to the nearest hundredth the circumference of a circle with radius 1 foot 9 inches. All right. Example 2. Radius now. 1 foot 9 inches. I've got a composite unit there of feet and inches together, so I have to deal with that first of all. I either need to go all feet or all inches. Now the question is going to tell us find the nearest hundredth. The circle doesn't even say what unit, but looking at the answer, they want feet. So we're going to leave it all as feet. So I've got to take that 9 inches, do it off to the side if we have to. How do I convert 9 inches into feet? Well, I'm going to multiply it by something. And what's the something going to do? I want the feet to be up here, and I want the inches to be down here, so my inches cancel. I just got to remember what the conversion is between feet and inches. And we know 1 foot is 12 inches. Okay, so it's really 9 divided by 12. 9/12 of a foot. Well, 9 over 12, I can call that 3 over 4, can't I? 3/4 feet. And in this case, I'm kind of looking at the book as my guide. Remember, we had a problem in the last example where we left it as a fraction. Now the book turns this one into a decimal, so okay, fine. 0.75 feet. Okay, so that was just the fractional part. So what is my actual radius is 1 foot plus the 0.75, so 1.75 feet. Okay, that's my actual radius. Okay, we're finding circumference, right? Circumference, we said, is the formula is either pi times diameter, or we could think of that as 2 times pi times the radius. And since we have the radius, I'll think of it that way. So 2 times pi times 1.75 feet. Okay. 2 times pi times 1.75 feet equals 10.99 blah 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 10.99557. Again, the unit is just feet. Okay, but we were told to round again on this one now. Round to the nearest hundredth. So we're going to round to that spot right there. And you can see the 5 here is going to kick this up from 9 to 10, which kicks this one up from 9 to 10, which is going to kick that one up to an 11, right? So it's actually going to be 11.00 feet rounded off. Okay. There we go. Sweet. How about area of a circle? Example 3. Find the area of a circle whose radius is 8.5 meters. Okay, area of a circle is pi times the radius squared. Okay, we're given the radius. It's real straightforward. 8.5 meters squared. Okay, let's be cautious here. We're going to take pi times 8.5, but I'm only squaring the 8.5 part, right? I'm not squaring pi, right? order of operations, I'm going to square the 8.5, then I'm going to multiply by pi. The calculator, certain calculators are sophisticated to get that right. Otherwise, we would do the 8.5 squared first and then multiply by pi to be safe. But this one will get it right. 226.98006, okay? A lot of these units are garbage, right? They're not significant. Remember when we talk significant figures? Well, we want to round it off anyway. It tells us to round it to the nearest tenths. So that's going to be right there. Okay, so that 9 either stays a 9 or it gets bumped up, and it's going to get bumped up, isn't it? Oh, what's my unit, by the way? Meters squared. Units of area should have square something attached. So that 9 gets bumped up, and of course that causes the 6 to get bumped up here. So it's going to be 227.0. What's my units? Square meters. Meters squared. Alrighty. Areas and circumferences of a circle. That's all we're going to do. We'll trick it up just a hair here, but we're not going to do anything more than circumference and area of these circles. Example 4. Find the area to the nearest hundredth of the top of a circular tank with diameter 12 feet 8 inches. Look at this now. This is example 4. Find the area to the nearest hundredth of the top of a circular tank with diameter 12 feet 8 inches. But look at what it's showing it as a radius. It's calling it a diameter. Ooh, look at that. Well, it's the way it's crunching the numbers, it's treating it as a diameter. So this is really not correct here. This should be all the way across. Should be 12 feet 8 inches because that's the diameter, and that's how they're doing it in the formula. Okay, so okay, fine, fair enough. Example 3 or 4, pardon me. Okay, we're given a cylinder. It looks like it's a more complicated problem, but we're only asked to find the area of the top part. Okay, so it's just a circle. Okay, we don't have to think too much about it. And we're given a diameter of 12 feet 8 inches. The only thing we got to worry about here is the feet and the inches together. We should be consistent. We'll turn it all into feet. Okay, 8 inches. Let's just get rid of that part now and figure that out. 8 inches times, I want some kind of feet over inches here, so my inches cancel. So 1 foot is 12 inches, so I'm going to do that. I'm going to get 8 over 12 feet. Okay, now, what does the book do? The book leaves it as 8 over 12. Ay. Come on, book, be consistent, will you? What is 8 divided by 12? It's a repeating decimal, so okay, I can kind of see why we did that, but we could at least reduce it a little bit, but I think the book is just going to plug it all in the calculator here in a second anyway, so okay, that's fine. So what is my actual diameter? It's 12 feet plus 8 and 8 twelfths, so it's 12 and 8 twelfths feet. Okay, that's my actual diameter. Now I want to figure out area. Well, I said area is pi times radius squared, and I threw in another little formula that the book didn't say. Pi over 4 times d squared. Oh, that's really the same thing, because if you have the diameter, remember the radius is half of the diameter. Okay, let's just look at that quick little exercise. Radius is 1/2 of the diameter. So if I squared both sides, which is a thing you can do, if I have something equal to itself, I can square both sides. And here I get radius squared, and what do I get there? I get 1/2 times 1/2 times d, if I spell it all out, right? So what do I get there? Radius squared equals 1/4 times diameter squared. And that's just what I've got here. That's a 1/4 times diameter squared instead of an r squared. Okay, same thing. All right, so this is diameter. So we can say area equals pi divided by 4 times this diameter squared. Now this is a goofy thing. We're gonna have to stop and figure it out here because we don't wanna make a mistake here. Now the book's just going to turn it all into a decimal anyway, so that's the easiest way to do it, so we can do that as well. So area equals, how might we go in about doing that? Well, we know 8 divided by 12 is some decimal. That's 0.66666, so plus 12. So we've got 12.66666. We're going to square that. Okay, fine. And then we're going to multiply by pi and divide by 4. So times pi. And then, I could hit equals, or I can just divide by 4 in the same shot. So we're going to get 126.012, and we're going to round it off somewhere. What's our units, by the way, though? I forgot to put feet here, but it's going to be feet squared, right? Feet squared. Okay, what are we asked to round this to? Nearest hundredth. That's that 1 character right there, that digit of 1, so it's going to be 126. It's going to stay a 1.01 feet squared. Okay? All good there? So, we knew the diameter. The picture was a little confusing because it was labeling it as a radius but calling it a diameter, but the calculation was consistent. It was a diameter. We had the feet and the inches to deal with, but otherwise calculating area. Alright, we're going to do one more example, and then really that's it for this section. We're skipping a lot of this section that goes more into the angles and all that good stuff, the degrees and the radians, and very important stuff if you're going into any higher level math for sure. But for our class, we're not going to cover it, okay? So example 5. We've got a 15-inch diameter wheel, has a 3-inch hole in the middle. So we got some big old wheel here, and then we got a hole in the middle. Okay? So we know the big wheel here is 15-inch diameters. Remember big wheels? I'm dating myself. I remember big wheels. Okay, 15-inch diameter wheel, and then the little guy here is 3-inch diameter. A 15-inch diameter wheel has a 3-inch hole in the center. Find the area of the side of the wheel. So I want to find this shaded area here, okay? So not the hole, in other words, okay? It's obvious what we're going to do, right? We're going to find the area of the big circle, and then we're going to subtract away the area of the little circle, right? So area, I'll just call it big, is pi r squared, okay? Or if we're given diameters, it can be pi over 4 times diameter squared, okay? So area of the big is going to be pi over 4 times 15 inches squared. What's that going to be for us? Pi divided by 4 times 15 squared equals 176.7145 inches squared. We'll do some rounding at the end here, so I'll leave all those decimals. Okay, that's the big one. Area of the small one, same formula, pi over 4 times d squared. Okay, but my diameter, of course, is a lot smaller in this case, 3 inches squared. Area of the small one, pi divided by 4 times 3 squared is 9. I'll just type a 9 in there. 7.0685. Again, inches squared, square inches. I want to know what's the area just of the part in between, okay? What am I supposed to round this to? The nearest tenth when we get there. So area is going to be area of the big minus area of the small. So 176.7145 square inches minus 7.0685 square inches. What do we get there? 176.7145 minus 7.0685 equals 169.646 inches squared, and I was asked to round it to the nearest tenth, I believe, right? Yeah, so we're going to round it to there, so the 6 will remain a 6, right? So area equals 169.6 square inches. Okay? Alright, that's it. Area and circumference of circles is all we're going to cover. You see the next examples takes it up several notches now, talking about angles and things that we did not talk about, and degrees and radians and good stuff that, again, fun for another class, but not for us. There's going to be one more section here. I don't know if it's how many more videos, but one more section of new material. That'll be section 17-4, and then we'll have some talk about our exam number 3 coming up and our final exam.